Welcome to my YouTube channel, uh, Pearson and Excel International Maths by Mr. Kamotho, and today in this video we continue to explain Pure Mathematics 1, and we are still dealing with topic number 8, which is differentiation. And today I want us to look at example 5, and this is on page 158. And we need to first of all understand, or rather remember, what the basic differential is all about, because we are told to find dy dx, or rather the gradient, when y equals part a 7x cubed. Now this one is just a way of saying y is equal 7x cubed. So if this is the case, what is dy dx? The old index, or the original index, is multiplied by the coefficient, and it's going to give us 21x, and the new index is reduced by 1, and that is the end of the story. In part B, when y is equals to minus 4x raised to power a half, then dy dx becomes a half times minus 4 becomes minus 2x raised to power minus a half. And of course, that is it, because a half minus 1 is negative a half. But it is not in its simplest form, because we are not expected to find variables with negative indices. So the final submission is minus 2 all over, because minus 2 is a coefficient, all over x raised to power a half, and this is easily the square root of x. That is just like that. Part C, y is equals to 3x minus 2, and if this is the case, dy dx is supposed to be, of course, minus 2 times 3, negative 6x minus 3. Again, you're supposed to write it negative 6 over x cubed. Part D, we are talking of y is equals to 8x raised to power 7 all over 3x. And as such, remember that there is some work to be done here. There is just some work to be done here, because we have x at the numerator and x at the denominator. First of all, we must know that this x and this x are going to be operated upon, and because it's division, then we are supposed to divide the powers, or rather to subtract the powers. So x power 7 minus 1 is going to be x power 6. So we can rewrite this one as 8 over 3 x power 6, and dy dx becomes 6 times the whole of this, 6 times 8 over 3, of course, with x raised to power 5. We simplify this, we have by 3 1 by 3 2, and it's ending up being 16x power 5, and that is just like it. And part E, we are saying that y is equals to the root of 36x cubed, But here you can see we have two types of numbers. We have constants and we have variables, and both of them are under the same square root. So it is very advisable that if this is the case, then we can separate the two and write it root 36 multiplied by the root of x cubed. And this one gives you already 6 multiplied by x raised to power multiplied by x cubed, which is raised to power a half, because the root is at the same time saying power a half. And this one is and if you follow what you followed, I doubt this was clear. The root of 36x cubed is, you can separate the 2 and write root 36 multiplied by the root of x cubed. And directly the square root of 36 is 6, and the root of x cubed can just be written as x cubed raised to power half, because the root is, in other words, called power half. You can rewrite it that way. So you can have your y to be equals to 6x raised to power 3 over 2, because you remember when we said a raised to power a multiply, or again raised to power b, this is a raised to power ab, the product of the two numbers. At the same time, now dy dx becomes 3 over 2 times 6, because those are coefficients. This is 3 over 2 times 6 coefficient, multiplied by x, which is 3 over 2 minus 1. Of course, this is 1.5 minus 1, which is a half. So if you simplify this, you'll simply get by 2 by 2 2 by 2 1 by 2 3, which is going to give us 9x power half. If you don't like this, then you can say 9 and the root of x. Either way, you have the correct answer. But yes, that is the end of example 5. Please know we've used basic principles, and we have really gotten home. All right.